It's widely known that air pollution is having a significant impact on human health. To better understand how personal exposure to air pollution can impact an individual's health, Cambridge University chemist Lia Hadifyaku is working on wearable monitors that she hopes one day could become part of our daily lives, just as we might monitor how many steps we've walked, for instance. So, each armed with a personal air pollution monitor, or PAM, a little grey box with a black strap, pretty lightweight, about the size of a digital camera, Leah and myself took a walk from the chemistry department on Lensfield Road across a very busy junction to Parker's Piece in central Cambridge.
So currently the box records air pollution measurements from gaseous pollutants and also particulate matter as we go about. It also records our GPS coordinates, so we would know where you've been and what kind of levels you've been exposed to. It also records our physical activity levels, so we know how much air pollution you are breathing in as you walk.
So does it stand to reason that the more active I'm being, the heavier I'm going to be breathing, therefore the more pollutants I'm breathing in? Is that right?
Precisely, your intake will increase when your physical levels are higher.
So Leah, we're coming to a bit of a quieter area now. We've come off the intersection and we're heading on to Parker's Piece. Just as we're walking, I cycle around Cambridge all the time and I feel like sometimes I can actually taste air pollution.
Yes, I think that you can taste air pollution because nerves in the mouth and in the nose are sensitive to that.
And is there any point in me trying to adjust my breathing if I'm behind a lorry or something like that? Is there much I can do, I guess?
I would suggest to use less busy streets, if possible.
Back in the office, Leah pulled up some data from a similar walk.
We carried a number of pumps and trying to see how reproducible are the measurements that they take. So we start from the department. We walk down Lensfield Road and in front of Parker's Piece all the way to a cafe. We stop there for some cake.
Excellent.
And then we come back. And you can see how much variability there is when we're walking outside, with spikes happening next to the major intersections, and also higher levels in the cafe compared to the lab. That shows us that it is more exposed to the pollution on the street that comes inside.
Is this massively surprising, or is this what you would expect?
I did expect that, but honestly, these levels are quite high. That was surprising for me, the scale of exposure.
So what's the idea with these personal sensors?
I think it's particularly relevant to people who are susceptible to air pollution, like people with chronic diseases, asthmatic children, and generally vulnerable populations. But as the prices go down and they become more accurate, I think that it will be part of our daily life, the same way that we record our daily steps.
Okay, so it could even one day be an app in someone's smartphone. Why not check the levels of air pollution as you're checking where the nearest coffee shop is?
Exactly, maybe having a very small cheap sensor on you that gives you information on that and probably protects you at real time.
Leah Hadifyaku there. Now, it's one thing to quantify the air pollution exposure that one person might be experiencing. It's a whole other ballgame to do the same for an entire city. There are instruments capable of doing this, but the problem is resolution. Just like how a low-res image can look a bit fuzzy if you zoom in on it, widely spaced measurements of air pollution across a city don't give you the most detailed picture of air quality in each street or neighbourhood. Lekan Popola is also a Cambridge University chemist, and I joined him on the roof of Cambridge University's chemistry department. It's not a bad day for it, actually. You could
Yes.
pay to go to the top of the tower to get this view from Cambridge.
I'm Lekan Popola. I'm an atmospheric scientist. So my interest is actually looking at air quality and how we use low-cost sensors to actually do air quality monitoring. I'm interested in the data analysis and looking at how policy can impact on air quality. And one way of doing this is to get additional measurement using highly dense sensor network. And this is becoming an emerging research field to the existing way of understanding how we study air quality. So essentially, my research looks at utilizing this technology to answer these questions.
And why have you brought me to the roof of the chemistry department?
So the reason why we've come up here is to show you some of the facility we use up here to do some of the research I'm involved in. So the facility we have on the roof here allows us to assess the performance of this low-cost sensor technology against the traditional reference instrumentation.
There's a few interesting noises, buzzes, some high-pitched noises. There's a kind of grid system. It looks a bit like scaffolding. And then on the scaffolding, as it were, there's a lot of little white triangular boxes, lots of leads and wires. What on earth is going on?
So what this small box you're seeing here, what it's doing is it's sampling the regulated gases, so CO, NO, NO2, and particulate matter, and it's sending the data live onto a server. We would be comparing that with our reference instruments.
And is this setup the way that air pollution is usually monitored?
Currently, the setup for monitoring air quality, at least as regulated bodies are doing it, is not using this low-cost sensor. But the idea is now the policymakers and the scientific community are actually trying to pick on using this instrumentation as a complementary method for doing air quality monitoring. So the standard way of doing it is to use the reference instruments, which are very sparse. And one of those is the big kit you see behind there.
Ah, the big grey box that looks a bit like a fridge.
Yes. So that's one way of measuring the PM. These instruments are very low-cost, portable, and you can have a high-dense sensor network of this instrumentation. Whereas when you use the classical, traditional reference instrumentation, even though those give you very, very accurate data sets, because they are very robust and big and elaborate, it's very difficult to have a network of those. And air quality is highly variable in space and time. So having a high-dense sensor network gives us a better understanding of the variability.
What gases are actually being measured here?
The gases of interest for us are carbon monoxide, CO, nitric oxide, NO, nitric dioxide, NO2. We also measure ozone, which is a secondary pollutant, is not directly emitted. We also measure particulate matter, so PM 2.5, PM 10. These are particles that are of interest in terms of human health, because depending on the size, they get into the lungs or they might get straight into the blood circulatory system. We also have a meteorological station here. And one thing that is important with air quality is that we have to also be able to tie meteorology into the measurement we're making, because meteorology also plays a key role in how pollution level varies from season and also on a daily basis. What we do is we look at the meteorological data, and if we see some anomaly in our data set, we can actually use that to actually give us a better understanding of what's actually going on. So a good example is during summertime, the atmosphere is very dynamic and variable. You get more mixing, and that dilutes out the pollution. Whereas in winter, the atmosphere is very stable, and you get buildup of pollution. And it's actually important for us to use the meteorological data to actually separate these two phenomena. And we can tell what the absolute emission is by comparing the measurement data, the gas or pollutant measurement data relative to the meteorological data set.
Back in the office, Lekan had gathered together a few years of air pollution data measured by the reference instruments. And funnily enough, these just happened to be around late Maybank holidays in Cambridge.
On the y-axis, you have what you can call the concentration of nitric oxide, NO, and nitrogen dioxide, NO2. And these are key signature for emission coming from traffic. So we hopefully will be able to see if there's an impact of low traffic volume over the bank holiday.
Oh, sure, because everyone's watching the telly or out in the garden. They're not driving to work, dropping the kids off at school, that kind of thing.
Yes, and hopefully we'll be able to pick that out. If we look at the example of the bank holiday in 2017 here, the first 5 days is a normal working day. And you can see the levels of the NO and NO2 emissions related to morning rush hours. And you have late evenings where there's actually nothing. So that's why you're having this diurnal cycle. Then this is the bank holiday Friday kicking in. There's still a bit of signal there, then all of a sudden there's a damping of the signal for the next 3 days. So that's the bank holiday Monday.
Oh, wow, that's really stark. So I guess on the Friday late morning, people are getting in their cars to go and visit the in-laws or whatever they're doing,
Yes.
and then they're not driving around for a good couple of days. That's really stark.
Yes, so and this is what we expect, especially for a city like Cambridge, where most of the emissions are dominated by road traffic.
The low-cost kind of sensors that Lekan is studying have been deployed around London as part of the Breathe London project to bolster the existing air monitoring infrastructure in the capital. The aim of having better resolution data on air quality is to inform policymakers about how policy changes are actually impacting air quality. And it's not just London that stands to benefit.
Part of the aim of the Breathe London is to try and use low-cost sensor technology and also mobile measurement. And we want to couple that with models to actually better understand pollution within London and see the impact of some of the policies that are being introduced in London. And hopefully this will be a template that can now be implemented in other cities across the world. So this work will be revolutionary with regard to us understanding ambient air pollution and how that can be properly quantified. There's also a modeling aspect. So the mobile data from the 2 Google cars going around and the static data are also going to be integrated within this state-of-the-art air pollution model to forecast pollution for London. And that can be represented in other cities as well.
Thanks very much to Lekan Popola there, and before him, you heard from Leah Hadithiaku.